Hello everyone, so we are here with JR0ch in Montreal. We'll be recording a podcast soon, but also we have a write-up of an amazing SSRF with a crazy impact for you, and we'll go through the back. So thank you so much for willing to talk us through the write-up, and can you start maybe what's the product, what were you testing, how did you discover the functionality?
Sure, yeah, thanks for having me. So the product was a mix of like Jira in terms of like a ticketing system or Jira service desk, a mix of like Workday for HR stuff, and a mix of Monday.com or like other project management products. So it was a huge platform, a huge product. And the way it works, every customer has their own tenant. For example, there would be greg.product.com, there would be JR0ch17.product.com, and the customer can decide where they want to host it, on AWS, GCP, or Azure. It's a cloud service.
Yeah.
And when you browse to one of these tenants, which are all public because it's on the cloud, in the login flow, there's an API endpoint that calls like metadata service to check whether the tenant is configured through SAML, OAuth, or just like a basic username password form.
Yeah.
And that endpoint, it discloses data which is not sensitive, it's public.
Because it's basically my browser asking, does JR0ch.product.com, like, which login form does it use?
Exactly.
So
yeah.
it's public, unauthenticated, everything that we like.
Right. And that specific endpoint, you could put in any tenant. For example, I could use greg.product.com to fetch the data from jroch.tenant.com. So what I did, I played with it a bit, put in like any tenant, and I noticed that it does fetch the data, even if it's not the same tenant.
Yeah.
Which was not necessarily interesting because it's public data, but still it was like a...
Yeah, but it's questionable, why do they need it?
Exactly,
Yes.
and your hacker mind starts working,
exactly.
Yeah. And then when we put in an invalid, or not invalid, sorry, a tenant that does not exist within the environment, for example, google.com, it will give an error message saying the host is invalid.
Yeah.
It has to respect this particular regular expression.
Yeah.
And that regular expression was really interesting. It was quite detailed. It did tell you exactly like how many parts of the URL had to exist. So it was like, for example, greg.production.product.com and all other environments. There had to be like 4 pieces in the URL. And then there were also a mix of TLDs and domains. So it could be, let's say, product.com, it could be product.dev, it could be tenant.com, tenant.dev, or even like products-dev.com. And so there were many possibilities. Yeah. I had seen it at a point in the past. I thought I tested it correctly. Turns out I did not. So I tested it again, obviously, else I wouldn't talk about it.
Yeah.
So I looked at every single possibility of domains that I could use. All of them were obviously owned by the company itself, but one in particular, one that used -dev dot a particular TLD, was not registered.
Yeah.
So I bought the domain, created a subdomain specific to what I needed to respect the regular expression, spin up a web server on it, and then put in my own server with that new domain as the value of the parameter, made a request to it, and indeed it made a request to my server.
Yeah, so the thing was the regular expression. Let's say it was in one bracket there was greg or greg-dev, and then there were a few TLDs, because normally there is greg.com and maybe there is greg.eu, but because regular expression can be, all combinations can be valid.
Right.
Maybe there was greg-qa, and maybe greg-qa.com existed, but greg-qa.eu didn't.
Correct.
And it was an unregistered domain.
Right.
Yeah, yeah, I
So I took advantage of it,
Yeah.
bought it, and
Yeah,
was
exactly.
hoping to get something, and I guess it worked. So when I put in that domain, got a request on my server. In the response, I did get like an error message showing that something is wrong,
Yeah.
because my server did not respond with what it was expecting. And also because, well, actually mainly because the endpoint that I made a request to on my server did not exist.
Yeah.
So when it called that, when I made a request to that URL, it made it to a specific API endpoint. So I created that API endpoint on my Nginx server. I made a redirect to Brook Collaborator URL. Made the request again, and in the response to the request, I had the contents of the Brook Collaborator URL. So
That's always
a
an
good
amazing
start to an
feeling.
SSRF, yeah. So I knew that I could fetch contents from external sources. Now the goal was to get internal sources.
Yeah.
So obviously the first thing that we usually try is putting the AWS metadata IP. So 169.254,
Yeah.
everybody knows that IP.
Yeah.
And did not work. I got a 401. And just to specify, I put that IP in the redirect inside of my Nginx config. So when the server made a request to the API endpoint, I redirected it to an internal resource. So I got a 401, indicating that they were most likely using this version 2 of IMDS, I think it's called.
Yeah. So the one that requires a header, which
Exactly.
if we only control the URL.
Right.
it's
And
hard.
unfortunately, I did not have the possibility to add headers, so it was I was stuck with a get.
Yeah, I think there's a problem. There's a common problem that we have an SSRF, but if the metadata doesn't work, we're stuck. So
Yeah, usually. In this case, I reported it as is, and figured I'll poke around and see if I can improve impact. So I spent a couple of, I think, hours on it. And that product, I had worked on it for about a year of like constantly going back to it. So I already knew an internal domain. I had it in my notes. I had found other SSRFs where I poked around inside of that domain. That domain is quite particular because the domain is public, but the IPs or the subdomains on it are public as well. Some IPs are internal. So for example, when we do like a ping, we'll see that it pings to a 10 dot something IP showing that it's internal. So I tried with those like IPs first and or those internal assets, and it did work.
Oh.
So it showed that I could hit internal assets. And the IPs that actually have public IPs inside of that domain, they're public because the IPs are public, but we can't actually hit them because either they're inside like a VPC where only IPs coming in from the tenant itself is able to get to, or if it's firewalled, I'm not sure. But the public IPs are still considered like internal data. So I did a recon on that domain, got a ton of subdomains. Also did create like my own word list from stuff that I saw within the application, and then found one in particular. It was related to an email service, and so when I hit that asset through the SSRF, it showed me a list of emails. I was like, that's interesting.
Yeah, that's interesting.
It, like a JSON of like emails that are sent. It's like an SMTP.
Yeah, and
SMTP service, or
those were not your emails.
It was not. It was a list of emails that were sent by all of the tenants, all of the product.
If we can go back, you said you created the word list based on your previous experience with the target. How did you do it?
Through time, I noticed that with the help of like error messages, some service names were disclosed. And for example, the product has like a slash, let's say, his slash history.
Yeah.
I was able to see that the internal asset name would be history-service-prod .internaldomain.com.
Okay.
So I was able to like determine how they name their internal services.
Yeah. Yeah, that really shows a lot of experience with the target.
Yes, and like again, like I was able to get a few of them to confirm that this is how they usually do things.
Yeah.
And I could also change, for example, history-service to -QA and other environments, and it would still work, as long as the hosting provider is the same.
Yeah.
Because the way that they named it for AWS versus GCP was a bit different.
Yeah.
And my test tenant was on AWS, so I knew exactly what to do on the AWS environment. So I put in a list of subdomains, hit one where it was related to like receiving or sending emails. And like I said, it was emails that I did not send. It was related to like other tenants.
Yeah, that's very juicy.
So I looked at the documentation from that specific service that was hitting. It turns out they had a couple of API endpoints where you could do like API /list. It would list all emails, like the title and who sent it and who it was sent to. And then if you did like along with the ID of the email, for example, 1 to 200, for example. Yeah. And if I did like API /mail/1, it would give me the contents of the email.
So that's basically all emails ever sent to all tenants.
Not ever, because at one point it like rotated.
Okay.
To like I think 100. After 100, let's say the 101st. No, sorry. Let's say someone sends an email. It's ID number 1. When the 100 emails later hits, the first one disappears.
Yeah, I see.
So just constantly rotates.
So it's like the queue.
A queue, yeah, pretty much.
Yeah.
So it's like a proxy, I guess, for the mail.
Yeah.
And it disclosed the contents. I could see everything that was inside of it. So to show impact, since I was kind of stuck with the IMDS not working, my impact was like not too great. And I guess with this SSRF, my thought was, let me just reset a user's password, see if the email goes through. And it did. So I was able to, well, I could have reset any single users from any single tenant as password. The email would be sent to the user. I would intercept that email through my SSRF, get the link to the password reset link, reset the password, and then obviously ATO.
Yeah, this is incredible.
Yeah, it's the first time that I had an SSRF where it impacted like users this way. Usually it impacts like the infrastructure where you can get like RCE or like through any other means or whatnot. Can access to other assets. But this one was like an SSRF where hitting the infrastructure was a bit limited, but I was able to find an asset which was affecting users. So in the end, obviously it's like ATO on every single customer, arbitrary ATO by using an unauth SSRF, which of course in the end had a CVSS impact of 10. And rewarded, fortunately, accordingly.
Yeah, and there's also with testing these type of services where each company has their own instance. And usually it's hard to get the perfect CVSS because you don't have a lot of attack surface with no authentication. So you often start with like privileges required low or something like this, or you just have an impact within the organization. So this is an amazing bug when it's unauthenticated, works on every tenant, and the impact is there, no interaction as well.
Good point, because I did not mention that, but every single tenant is like really isolated. Like it's pretty much like its own, I guess maybe even the VPC. I'm not sure how it's done internally, but it's like its own separate network. It's really isolated one to the other. Like I looked at that app for a while, and I was not able to fetch data from one tenant to the other. It's like it doesn't exist. And like you said, it's an SSRF on all tenants. So with the SSRF, I was still able to fetch like internal data within the customer itself. So I was able to get information from each customer. Obviously, their users, ATO. So and this worked on GCP, on AWS, on Azure. It's like the client was able to choose on which environment they wanted their tenant to be hosted in. So it was a pretty cool impact for SSRF.
Pretty cool impact in understatement. Awesome. Thank you so much. If you enjoyed the bug, make sure to subscribe to also listen to our interview, which will be published in 2 weeks. For now, thank you so much for watching and goodbye.